Hello, and welcome back to my series on migrating a Cisco Catalyst switch to a Juniper EX switch. We're almost done. In our last video, we cut over our production EX switch with our fully migrated configuration. We've got VLANs, we've got connected clients, we're now uplinked to our WAN gateway, we're getting DHCP addresses to those clients, we can get out to the internet. We basically have all the pieces in place for a production switch. The only missing bit at this point is making sure that this switch is buttoned up in such a way that no one else can get into it except us and mess with the config. And that's what we're going to do in this video today. Before we start configuring our switch, I want to highlight a couple resources that you can use to help you in your network. The best place to start for hardening is, go figure, the Juniper Hardening Junos Devices Guide 2nd edition. You can find this by going to juniper.net and searching for that name, or by going to Google and just looking for Juniper Day 1 guides. These are all downloadable for free, and this guide in particular includes instructions for how to harden at different levels, really buttoned up versus, maybe a little bit looser depending on what your specific environment is, and even has a really slick checklist. The next thing to understand about Juniper, particularly if you're coming over from iOS, is where we apply these rules. If you're used to iOS, then you're used to creating an access control list and then applying that access control list as an access group, an access list. I know it can vary depending on where you are in the config. But for logging in, like SSH specifically, you would apply that to the VTY terminal. In Juniper, I think we make this pretty straightforward because we use the loopback interface essentially as the gateway to the control plane. Now we have documentation on this, and I've got it on the screen now, but what you need to think about in your head is just this. If you want to protect the switch, you don't have to apply filters to any of the interfaces, the physical or logical interfaces. You apply them to the loopback. That doesn't even mean that you need to have an IP address on the loopback. That just means that you have to define the loopback with a family INET and then just do a filter in and then your filter, and that's it. Now we're not going to get too deep down the rabbit hole. My intention here is to just show you the structure, and once you kind of start to get it and it starts to click, you can build these rules out the way you like. Also, while you're doing this, remember that Juniper has a commit confirm structure. If you get this rule wrong, you can lock yourself out. However, if you have that commit confirmed, and by default it'll roll the config back in 10 minutes, or you can change it to maybe 1 or 2 minutes, that will save your bacon, because what it will do if you suddenly have a cursor that stops blinking or you can't access the device is, without you typing commit in a second time, it'll roll the config back to the previous state. You can log back in, figure out what you did wrong, and then address it and then recommit. We like to start from a zero trust mindset, which means that our rule is going to end with an explicit deny, and we are going to then allow specific things. In our case, you can see that list right over here. I'm not running any of these protocols, OSPF or BGP. I'm just going to show you what they look like when they're configured. So we'll get into our configuration, and where we go to configure our stateless filters is under firewall. Now that might take a little bit of getting used to, because you might be thinking of a firewall as something that's stateful, but that is not the case. Technically speaking, originally, OG network, firewall is a stateless filter. If you are on a security device from Juniper, you would go to the security section of the configuration to do your stateful filters. But since this is not a stateful device, we don't have that part of the configuration. So we go into Edit Firewall, and then we will define a family, and in this case, we're going to be applying an INET filter. You can't do L2 filters on L3 interfaces. So we'll go to Family INET, and I already have a Protect RE filter somewhat built here. So if we look at this, we can see that I've got some terms, and like you might expect, these are processed from the top and working their way down. And there's a terminating action, which means that if this says accept, it'll let the traffic through, and if it doesn't match this from, then it will pass to the next term. So we can see I've got my OSPF, I'm allowing it from my management subnet, and I've got a protocol of OSPF defined. Now BGP is a TCP protocol, so I have the same source address, but I have a protocol of TCP and then the destination port of BGP. You could also put in the port number if you wanted to here. You can also use source prefix lists. I mean, there's a lot of options in here. This is pretty vanilla. I'm allowing ping from any subnet. I don't really recommend that you do that in production, but this is just to kind of show how the rule sets work. And then I have a rule here for NTP. What I don't have is my SSH rule or my explicit deny at the end. So we're going to go ahead and put those in now. we'll edit the filter, protect RE, and then we'll do a set term, let's see, SSH allow from source address. And again, we'll let this from anywhere on the management subnet. And don't let from fool you. You can have source address, you can have destination address. From is just the match condition. So you don't think that from just means it's incoming. From is just whatever that match condition happens to be. And then we'll say protocol, oh, I got to do the source address, and then protocol SSH. Ooh. And then destination port SSH. There we go. SSH is not its own protocol. So if we take a look at this, you can see that. Now I'm missing the then statement. You always have to have an action. So we'll do set term SSH all, then we'll give it an action and we'll say accept. And now I also need to put my explicit deny in. So set term deny, then discard. You'll note that I don't have a from in this term. If you do not use from in a rule, it is a global match. So essentially any traffic that is processed and doesn't match one of these conditions and get explicitly accepted will match this term, because the from at this point is just catching everything. One other thing I want to show you, if we wanted to reorder this, we would use the insert term. Like say I wanted to put SSH all at the top because I know that that rule is going to get hit more than other rules and I want to process it first. I could do insert term SSH all before term OSPF allow. And if I look at it there, you can see that it's now ordered at the top. This is useful because obviously since this ends with a deny, if I were to add a new rule, it would come behind that deny, and I'd want to move that deny to the end. I'd probably just say insert deny after and then whatever the lowest rule was. So now we have this rule created, and now we have to go apply it. So like I said, we're going to have to go apply that to the loopback filter. So edit interfaces, and if I do a show LO0, which is our loopback, you'll see there's no configuration there. So I can either set or edit. I'll just set it from here. Set LO0.0 family inet filter input. I am going to do a commit confirmed, and I'm going to give it 2 minutes. And this is my get out of jail free card. If I have accidentally blocked myself from access, which I know I haven't done because I'm in via console, this is how I would do this. So commit confirmed, and you'll see a message pop up on the screen that says the configuration will be rolled back if I don't type commit again. There it is. That confirm is just a second commit. Also keep that in mind if you do want to do a rollback. This whole process does count as 2 commits, not just 1. So I'll do a commit and quit, and that'll lock that configuration in. Alrighty, now let's go see if it works. First, I'm going to get onto, actually I had kind of an order here. Let's get on to Pi 5. Now this is on the management interface, so this should be able to SSH to this device. There we go. So if config 0, we're on the correct subnet. We should be able to ping it because ping I left open. This should be 2. And let's do SSH root at 10.30.0.2. It asked me to load my RSA key. I could put in my password. Oh, and we're in. Perfect. All right, that's expected. That doesn't really tell us if it's working though, because I was able to do this before. So let's go on to Pi 4, which is on a non-management VLAN. And we'll confirm that real quick. If config eth0, all right, that is a 20, not a 30. Let's see if we can ping it. Now we should be able to do this, and we are allowing ping SSH root at 10.30.0.2, and we cannot reach it, and that is exactly the behavior we were looking for. Perfect. All right, so we've got our basic ACL in place here. Now let's go back to the configuration and talk a little bit about RSA keys. You can always just have local logins. We also support Radius, TACACS. But if you are going to be logging into this device with local accounts, even if they're service accounts, it's always a good idea to use a key pair, just a little bit of extra security. So let's create a key pair first. And actually we'll do that from Pi 5 because we need to have a private and public key, and then we put the public key onto this box. So we'll generate that key directly here on this Raspberry Pi that is already on this management subnet. And I've got that command here. You can see, so this is just a standard Linux command. Whatever platform you happen to be using, I've got a Linux box, Raspbian, but if you're on Windows, if you're using PuTTY, just find a guide, follow the guide. So let me create the key pair first, SSH keygen -F for the file name. It'll prompt you for this information if you don't put it in, so I'm just putting it in just to kind of, let's see here, actually I don't want to put it there, I want to put it in .sh, and then pi 5 underscore RSA dash type is RSA, and then it's R248. We do 4096. I'm pretty sure it's supported on the SRX 300. I'm just not playing with it right now. I'm not going to put a passphrase in. You can put a passphrase in if you want. I'm just not going to do it here for this one. I'm in my home directory. If I go to .sh and I do an ls, you'll see that I now have a private key right here and a public key right here. So I now need to copy this public key onto my EX. If you were just doing this from Linux system to Linux system, you would use this SSH copy ID command right here. You can use this and it will work. It's just only going to install a key pair for the root account, which doesn't do you, it doesn't help you with your other user accounts. What you really need to do is go create your user and then copy and paste the key pair in. So if you do a cat like 5 and actually just look at your public key, you're going to be copying this content into the configuration. So we'll go here, edit system, login, user, we'll just call them Pi 5, set class. Class is basically what permissions does this person have when they log in. I'm just going to give them the keys to the kingdom, call it super user, and then set authentication. We'll see we have a couple options here. Plain text password, which would auto encrypt, but this is how you would just type in a password. In this case, I'm not going to give it a password. We're just going to do SSH RSA here at the bottom. So SSH RSA, you can see I have this key string. Start and end it with a quotation. And then this copying can be a bit tricky. So sometimes you need to copy it to some intermediate state, like into a text box and then over. Let me copy this and we'll just see what it does. That looks like it's going to be okay, as long as it's copying it as one string and not trying to carry over the carriage returns. I'm going to delete that bit because we don't need that bit and hit enter. And there we go. Show. Oh, quit. Let's jump back over to our Pi, and if we SSH Pi 5 at 10.30.0.2, there's no password or any combination of information that we can put in here that's going to work. Now, if we do the same thing and add an identity file and do pi 5-rsa, drops us right in. See? Ta-da. Easy breezy, no password. That was the last thing. So if you have any questions, as always, put them in the comments below. I'd be happy to answer them. And if it requires a really involved answer, I'll do a really involved video. If not, we've got one video left in this series. And this is where we're going to actually build a virtual chassis. Should be a quick one because, well, we don't have to do anything with the other switches aside from power them on and then plug in virtual chassis cables. I'll go through some of the request options that we can use to do renumbering and move things around, and how we can pre-stage a configuration, some of the options we have for that pre-staging. Until then, hope you have a great night. It's nighttime where I'm at right now, and I managed to knock out 2 videos today, which is really awesome. Take care.